Well, Karl Havard, the COO of Nscale. And Nscale is a hyperscaler engineered purposely for AI. What we're doing slightly differently is we're purposely building a footprint from the ground up, so breaking ground on data centers all the way through to the software stack to create facilities to house generative AI compute power at scale. And that allows us to support other hyperscalers or other organizations that want to get into this industry in an ambitious way.
And I'm Clayton Wager. I lead our high performance team, including AI, for our web scale network infrastructure business. And really that's about delivering solutions that would help the communications of all these fantastic applications we have coming on board, whether it's scientific research, artificial intelligence.
What we think we're doing differently to others in the marketplace is we're offering generative AI services as a cloud, obviously, but we've also, a couple of years ago, we're ahead of the game when it came to accessing power at scale. So we've got sites of 1.2 gigawatts plus globally of capacity, which is currently the issue of the supply chain today. Previously, the supply chain issue was getting hold of the equipment, but actually the issue now is, I've got it, where do I put them? So what we're building out is purposely built generative AI data centers, but doing it in a way which we can create private clouds configured to our customers' needs. We can do it with 100% renewable energy, and being European, we can offer true sovereignty into the market as well, which unfortunately other public clouds from the US cannot do. So yeah.
Well, as we enter 2025, it's very clear that real estate and power are the long poles in the tent when it comes to building out this infrastructure. Everyone globally is really experiencing the same issue, and then when you have incentives in Europe, as you do around Scope 3 emissions, and all of the people are really looking for these type of solutions which serve not just the use case itself, but what you end up doing, which is providing a multifaceted approach to growing their AI infrastructure.
Yeah, and I probably haven't mentioned our fully integrated stacks, as well as the power, the infrastructure, etc. On top of that, we have the orchestration software which we're putting as well as a marketplace of software tools we can bring up. And of course, key part of that is networking. And as the market grows, networking becomes much more important because it'll be scale across multiple DCs, and therefore you need reliable, super fast, low latency networks to be able to put that mesh across the top and be able to support the big models that are currently being trained and also inferred. The trends that we're seeing is we could blame the manufacturers here, and that is they're making equipment here which requires much more power. And therefore, legacy data centers that maybe the public cloud set up 20 years ago are not necessarily fit for purpose to be able to house this equipment that's coming over the horizon. So rack powerage for the latest NVIDIA or the latest AMD, and it needs to be a much higher spec than it is today. And that's one of the key trends that we find ourselves actually slightly a bit ahead of the curve on, as I mentioned before, because we're building purposely for that. The other aspect as well, and probably a lot of prevalence in Europe around this, and that's renewable energy and sustainability and the ESG footprint that AI needs to bring. I think there's a lack of awareness in the market that the stuff behind AI and generative AI requires a lot of energy. Creating a video on TikTok or whatever it might be takes a lot of energy, and there's a lack of awareness in the public and in the business world associated to that. So we're trying to make sure that we offer true 100% renewable energy, but also to offer true cooling in the right way as well. So direct chip liquid cooling also. So yeah. Being non-technical and answering a question around Ethernet I'll talk about it from an open source point of view. I think Ethernet has been around for a long time. People understand the stack, understand what's required, and the protocol within it, and therefore it's going to be much more widely adopted than proprietary protocols. It's a little bit like open source software, isn't it? Where people are always contributing to it and making it better, as opposed to proprietary, where you have to buy and pay a license, etc. And that's why I think Ethernet will win out in the longer term, associated, especially when you're going global and you need to connect different things together.
When we're looking to build these new exciting applications, we have to start with the basics. We have to have equipment that's capable from a speeds and feeds, from a size and shape. You've mentioned power, which is critically important, being really thoughtful about the engineering in products and really reclaiming every single watt we can, because every single watt matters at the scale that we're talking about. Then you work your way up the stack from sort of the basics and say, how do we then manage the traffic and applications which are on top of that, right? And today we have some well-known ways to do that are widely understood and implemented in the marketplace. But it's very clear that AI specifically and high-performance computing are very dynamic areas of research. And so researchers might provide a way to, parallelize a model, or they might come up with a new sort of way to load in data. And as we look to that future, we as an industry really need to focus on ways that we can standardize that. It helps the procurement process, it helps business value, it allows folks like you to move faster and offer those services to your end customers.
The other thing is reliability. And that is, we know this technology in generative AI space, from a GPU or accelerator point of view, it can be prone to issues, and the RMA's stats aren't great. But you can sort of counter for that. So if a GPU goes pop, hot spare, put it in, the network goes down, your whole cluster goes down.
Again, these 100 billion, if you will, digital agents operating on our behalf, they're going to be located in the right place from a technology standpoint, from a business value standpoint. And one of the ways that we look at it within Nokia is that the networks that we've built over the years, whether it's a wireless network, a fixed access network, those end up being the last mile for these new AI agents. And so we know that today they live in data centers, but they will quickly make their way out to the edge of the network for performance reasons, or perhaps for data sovereignty reasons, or just business value. And so understanding the carrier grade aspects of a wide area network, connecting the data centers together, very simply federating capacity. Perhaps you don't have the power or the space or the capability in one particular location. You want to start gathering them together and having them operate as a single autonomous unit, but then being able to segment that and place it out into the really interesting places. Of course, we know that agents are going to run anywhere from our phone to the very largest data centers, and providing the communications paths between them that are reliable and of the right bandwidth, the right characteristics for the application is a key part of our future.
We've developed a modular DC solution purely for that use case. So at the edge, so research institutions, wherever the data sort of resides, getting close to that and configure it in a private cloud way for them. But again, useless without the network, because you've got that infrastructure already in place,
And we may find ourselves doing it to chase power availability in space. I mean, there's just, again, a multivariate problem of how we place these things. So having the luxury of a highly performant, rearrangeable network that can serve our needs is a key part of that future.
Yeah, totally.
So we're very excited to be part of the Ultra-Ethernet Consortium. We think that starting with Ethernet and IP and those scalable technologies is a great start, but Ultra-Ethernet gives us the ability to add a lot more in terms of security as a first-class citizen, capabilities and negotiation. It really allows for a standardization of designs and implementation that's going to be important to scale, right? And so as you look at Ultra-Ethernet, it's composable. So if you have a network that's built today, it might be capable for Ultra Ethernet, or there might be new products, but we're going to make sure that there's a high degree of compatibility because of generational concerns, right? Whether it's generations in the network, generations in the GPUs themselves. We need to be aware as an industry that if we want this to have legs, we need to be building with composable units and repeatability. Of course, it helps on the business side of procurement as well. It gives you a healthy ecosystem to make selections from.
Yeah, very good.
We talked about how part of your core value proposition is having these a network that can be composed to deliver AI, whether it's in a data center or farther on the edge. Talk a little bit about your thought process from a business or a technology standpoint, how you get your team together to make those decisions so that you have something which is future-proof.
Yeah, it's interesting because at the moment we're sort of dictated by customer needs, and therefore the way the market is at the moment, I think it'll look very different in 18 months to 2 years' time. So at the moment it's other hyperscalers, it's model makers, etc., where they have a defined view of what they need, and typically it's within a single entity. But we know already the market's maturing, enterprises are coming in, they're wanting a more distributed, because of their organisation, the distributed across the globe way of doing things, whether it's training or tuning models, etc. And therefore they can't rely upon a single instance, and therefore they want to have spread geographically. They want sovereignty as well, and then they also want it at the edge. So you've got this complexity going on, so we need to create some form of consistency and conformity that can deliver our customers today, but also have an eye on the future. In order that we don't 1.2 gigawatts of power with access to more, we're constantly not reliant upon the grid to be able to provide that. So we are locating our data centers. We've already got one of our flagships up in north of Norway, Glomfjord, just inside the Arctic Circle. And it's 100% renewable energy from hydro, and it also uses the natural environment for cooling as well. And our aim is to always use 100% renewable energy to be able to fuel our expansion and our growth going forward. And also the ability to offer our customers to see exactly what their footprint is. And therefore they can see firsthand if they're training a model on a certain number of accelerated GPUs, they're using the network for a certain period of time, they should be able to see a real-time dashboard of exactly what their energy usage is and carbon footprint is associated with that. We want to create awareness in the industry to do that.
Well, we've been very excited to work with Nscale to date. This is it's been a great process for us, learning about you, learning about the marketplace.
It's nice to work with an established organisation like Nokia, because Nscale is still in its early days. It's still in its infancy. We are, honoured to be backed by serious investment, which allows us to get excited about where we're going to go to the future. And therefore, I can only see, a long-term relationship, beyond the horizon of wherever the market takes us, whatever new technology comes in, based upon the foundation that you're building, it seems to be a key ingredient of our success going forward. So yeah.
Well, we appreciate the partnership. Thank you for joining us today.